Okay. Hi, everyone. We're just going to wait for a couple more people to stream in, and then we'll get started. But thanks, everyone, for coming to our talk entitled Breaking the Mold, where we're going to be talking about kind of a smarter approach to data testing that we found works in our experience at a data team at Aiven, which is kind of a rapidly evolving company. So before we get started, I'll start us off with some introductions. So I'm Emiel Verkade. I'm an analytics engineer at Aiven, and this is...
And I'm Anton Heikinheimo. I'm a senior data engineer.
Yeah, and we sit in the central analytics team at Aiven, so we're not really here to talk about or sell what Aiven does, but more just talk about our experience as data practitioners in the field. So hopefully that's a sigh of relief from everyone here in the hall. Basically, at Aiven, the central analytics team has a bunch of distributed analysts embedded in different teams, and we also have general analytics engineers, data engineers that are kind of part of servicing the entire organization. And the main service that our team provides is creating and maintaining a data platform for the wider org. So we're responsible for things like ingesting new data sources, creating data models for other teams, managing reverse ETL tools, probably stuff that everyone here is very familiar with. I do have to talk a little bit about Aiven. So Aiven provides managed open source data technologies on all major cloud platforms. And Aiven's mission statement is to be your trusted AI and data platform. So with that comes a lot of expectations around data quality, both for Aiven as a service itself, but also for us as an internal team within that organization. And kind of a year ago, we were scratching our heads a bit and thinking we might do a quick assessment of where our own internal data team is at when it comes to data quality and quality of service that the data team offers. And we realized that we weren't really up to snuff. We weren't really up to where we wanted to be. And we kind of looked at the data quality, data testing landscape in general and thought there's quite a few problems there that, in our opinion, not many people seem to be talking about. So this talk is really going to explore the things that we've learned and the experiences that we've had around our testing philosophy. So before I dive in, high-level agenda. Basically, we're going to talk a little bit about testing, what it's supposed to achieve, and roughly what we see as the current status quo. Then we'll talk about how these practices, the kind of best practices that we currently have, often lead to a decrease in data quality and trust, which we found kind of surprising. And then we'll go over some approaches that we've taken to try and overcome some of these issues. Then we'll wrap it up and try and hammer home some of the key points that we've made. So we'll start with a little story about analytics engineering at Aiven roughly a year ago. And maybe, hopefully, some of you can relate to some of the things that we were experiencing. But to start, I'd open up my laptop nice and early, try and get ahead of some Jira tickets that are piling up. And I see this lovely icon on my dock or on my taskbar. I'm sure you've all seen it before. Whether it's Slack or Teams doesn't really matter. But in my case, I'm compelled to open up Slack, and I see messages from confused and frustrated stakeholders about data pipelines failing, data not being in the right place, issues cropping up left, right, and center. So I have some data alerts like these. Looking a little closer at these three specific alerts, we don't actually have to. It's not super important. But there, you can see that there's a few tables that have single records with null values in them where you might not expect them. And that's causing a bunch of data issues further down the pipeline. So, I've had my coffee. I'm combing through all of these alerts and messages, these 999 of them. And I kind of have a rough idea of what I want to prioritize and which tickets or which issues I'm going to deal with first. And then I get started trying to triage the problem. So I'm chatting with stakeholders, I'm trying to figure out what's changed and how to fix it. I'm implementing a solution, testing it, deploying that to production, doing one final sense check before updating stakeholders that the data is ready. All of this before lunch, by the way. And that's one problem down, and then another 998 to go. That seems a little bit crazy. And I'm thinking to myself, super frustrated, it can't be that I've followed all of these data testing best practices, and yet, not every morning, but a lot of mornings end up looking like this, where I'm just chasing behind the facts. Stakeholders are annoyed and confused because data isn't in the right place, and I haven't even made any progress on my backlog, on doing the actual things that add value to the organization. So at some point, a light bulb goes off. I smell kind of the metaphorical fire in the room, and I realize, hey, I should probably think of a different approach to get out of this situation. Whatever I've been doing, whatever best practices I've been following, don't seem to be working, at least not for me. So this talk is about us promising that it can and it does get better, and we're going to show you how that happens. But before that, I'll talk about some of the kind of major issues that we were facing. So we spent 6 months implementing a bunch of data quality tests and processes. We were adding, kind of what DBT just showed at their keynote. Maybe you have some fancy AI that adds a bunch of not null tests to all the columns in your model. But what is the actual end result? We basically have that data ends up coming quite late. You have issues in the data pipeline, like some of the data issues we saw earlier, where there might be one null value in a table that's not expecting any null values in that column, and that means all the downstream dependencies of that model are not being updated. You also have things like data being out of sync, so certain models are being updated, other models are not being updated. That all ends up being super annoying. You also have kind of the third point where bad data ends up in your tables anyways, right? The way that DBT orchestrates everything, you run the data transformation, then you run the tests after the fact, and DBT tells you, hey, there's a bunch of malaligned data in this table. Okay, great, but it's already in the table. So what do you want me to do about it? Your stakeholders can still model and see that malformed data. With so many data issues piling up, you also have to spend a lot of time thinking, what should I deal with first? And often you're not really, I don't know if it's just analytics engineers, but I'm not really the best at documenting exactly what I'm doing and how I'm doing it. So the way I might prioritize a certain bunch of issues would be different from Anton, would be different from anyone else on our team. So we're not really giving a uniform standard approach around how to deal with all these things. So all of these things together add up to bad data quality. One thing I do want to say from our perspective is data quality to us means not only the quality of the data in your database or being served to your end users itself, but also the service in general that the data and the data team provides. So what does that mean for us? It means in scenarios where data is arriving late, that the problem of data arriving late was often bigger than the problem that there might be one or two records in a table that are having some null values in certain columns. So we were trying to basically take a more holistic approach and a more holistic view of data quality, rather than just saying it's about having the data in your tables conform to exactly the expectations that you have on that data. So for us, the big thing we found was that when we actually started removing some of these data tests, and when we started kind of being a little bit more mindful and methodical around what things we're actually testing in our data models, we found that data was arriving on time, like data quality in that sense was improving. And so for us, the act of adding tests, the very thing that was supposed to improve data quality, was actually a leading cause of bad data quality at Aiven. So one of our key learnings that hopefully you guys will have as well is that when starting to tackle data quality, we don't put enough emphasis on data uptime. We think one of the reasons for this is that we're kind of fundamentally misusing and over-leveraging data tests for purposes that they weren't really built for. And so to highlight that point, let's have a little look at what data testing is all about and what the typical data setup looks like for testing. So to start, you kind of have your generic architecture here, where you have incoming data on the left, which we can broadly classify as source data coming from a number of different sources. Could be internal, could be external. We have expectations on what that data might look like, denoted by the assertions that are above that data on the left. And then this data then gets piped through our DBT project, where we apply logic on top of it. And then this data finally gets organized into output data through DBT models, typically in something like a MART or in your gold tables if you follow the medallion structure. This output data also has expectations layered on it, denoted by the assertions on the right. And let's quickly look at how these two assertions on the left and on the right of this diagram differ in their purpose. So the assertions we tack onto the left here are useful to test our assumptions about the source data, which, again, can be coming from external or internal sources. both of which might not have data contracts or any sort of QA frameworks embedded within them. These assertions then often take the form of dbt standard tests or a custom logical test that we can apply by writing SQL tests ourselves in dbt. In either case, we can orchestrate this whole thing just using dbt's kind of built-in test functionality. And then the tests on the left, these assertions on the left, are intended to test our assumptions about the logic that we've applied throughout our dbt project. So we've presumably already tested the source data. We know that it conforms to our expectations. When the input data has been verified by testing the output data, we're testing the underlying logic, making sure that all the transformations that we made in our dbt project actually end up yielding the result that we expected. Now that we've covered kind of typical architecture and thought a little bit about the role that tests play in that, I'll hand over to Anton to talk about how this pans out in practice and why sometimes this has some detrimental effects on data quality.
Awesome. Thank you, Emiel. So Emiel already kind of suggested that bad testing practices can worsen data quality as opposed to improve it. But let's have a closer look at how our experience confirms this. So to kind of understand how testing practices can contribute to bad data quality, let's just quickly understand the environment in which they operate, that is dbt build. So when you're running dbt build, and most of you know this, but let's just kind of set the stage. So when a test fails, it will stop any downstream models from updating. And we call this concept short-circuiting, and throughout this presentation, we'll be displaying short-circuiting in our illustrations with these red arrows. So looking at this specific scenario, 2 of our tests are failing, which leads to a situation where the bad data is now in this table called data, and downstream from that table, nothing is being updated until you attend to this failing test. Conceptually, though, that's a good thing, right? Because ideally, we isolate the bad data as early and as soon as possible, so that as few as possible downstream consumers are affected by this bad data. However, the process really puts emphasis on writing good tests. And from our experience, the process of writing tests in most companies look something like this. In a lot of organizations, kind of the purpose of testing is unclear, and it's typically tackled by trying to standardize the process through having kind of hard requirements of testing your models, or it's tackled by having vanity metrics such as test coverage. And we believe that these things really don't accurately reflect the impact of testing on data quality. So with that in mind, one of our 3 learnings was that more tests do not lead to better data quality. Actually, quite the opposite. So kind of moving on, back to this same scenario, what other issues are there in this setup? Well, you're running tests on data that you have very little control over. Kind of, as Emiel pointed out, tests serve a very important function in maintaining your assumptions about the source data. But when working in a fast-paced environment, your upstream producers are building out new features at an extremely rapid pace. And not every change in an upstream system warrants a short-circuiting dbt pipeline. So keep in mind, tests are really just point-in-time assertions that are true for that moment. And if the fix to a failing test is just to remove it, then it probably shouldn't have existed to begin with. These tests do not lead to improved data quality. But what do? They lead to a very miserable analytics engineer, Emiel, who will eventually and inevitably need to address those alerts when changes in your upstream producers start short-circuiting your dbt pipelines. So again, keep in mind when writing a test that they're really just point-in-time assertions about the data itself. And that brings us to our 3rd and final learning, which is be mindful of the full life cycle of the test, the technical debt it introduces, the warehousing costs it introduces. Like, don't get me wrong, it's really valuable and important to maintain our core assumptions about the data, but just be mindful of the technical debt. Okay, so moving on, we've kind of set the stage what the problem is, what our learnings have been kind of throughout this process of trying to improve our data quality, but let's kind of go more towards actual solutions. So how did we modify our testing practices to improve data quality? So reinventing how we test our data and build resilient dbt pipelines has been a long journey, and there's kind of multiple bigger changes we've implemented, but we asked ourselves, like, if there's one thing we want to share, what would that be? So what was like the one biggest single modification that had the biggest impact on data quality? So that's what we're going to be sharing here today. So let's just remind ourselves, what did Emiel teach us about dbt tests? So currently they're used to validate assumptions about the source data. So these are your dbt tests on dbt sources. They're used to verify correctness of logic when deploying changes. So this is more the tests on the dbt models themselves. However, in addition to this, tests are frequently used as well as a tool to build resiliency into your data pipelines. And we believe it definitely shouldn't be used for that. Kind of fundamentally, we believe the root of the problem is that dbt tests are used to solve problems that they weren't built to solve. And actually, misuse of dbt tests, as we previously saw, lead to really fragile pipelines. So what did we change? We actually changed the default severity of our tests to warning. As you can see in this illustration, the dbt pipeline continues to build even during a test failure. And this change really cemented the purpose of tests for us. Now we are applying tests to what they were fundamentally built for, without the downside of kind of short-circuiting the pipeline when our assumptions about the data do inevitably change. But this kind of raises the question, if not with dbt tests, then how do we build resiliency into our pipelines? Well, we argue that if your pipeline needs to short circuit when a condition isn't met, you should define that as a filter, not a test. So if your downstream consumers are reliant on data conforming to specific expectations, then you should embed those expectations directly in your SQL models. And for us, this is commonly the case in reverse ETL or machine learning pipelines, where the downstream consumers, for instance, Salesforce, kind of has specific expectations about what does the data need to look like. And for many of you, the initial thought is probably, isn't this an anti-pattern? Because if you define that as a filter, then actually those problems go unnoticed. And yes, short answer is yes, but it's something we consider. We have a solution for that in mind as well. But so elaborating further, what do we mean with these filters? So kind of as you can see here, previously we would write a dbt test where, say service types need to be these, and service type can't be null, which would lead to short-circuiting pipelines, which would lead to data downtime, data inconsistencies, and just a generic pain in the ass, really. So these days, instead of doing it as a test, we just go ahead and define that, embed that directly in the dbt model as a filter. This allows for data that matches our expectations to be updated in our key data set, and it doesn't have any negative impact on data uptime. Just kind of elaborating further on, or another example of how we do this, instead of a relationship test between these two models, we ensure that this is the case through this filter that only accepts records that are present in the parent model. In addition to the gains in uptime, it's also made sure that our data models stay in sync with each other. And kind of all of the current DBT tests are relatively trivial to implement as these types of filters. Your uniqueness, not null, accepted values, etc. But the issue with this approach kind of arises of how do you scale it? And how we scale this is, well, we actually don't go in every model and make sure to implement these as filters, because that just wouldn't scale. Rather, we maintain this central definitions in a YAML file. So kind of as you can see here, the filters are always applied on a column, but you can change the scope of that filter to be specifically within that model or within the scope of the entire DBT project. Then we apply this macro that retrieves these filters and applies them to that model. So kind of in this example where there's a global filter on service type and we apply this macro, it means kind of for every model where we apply it, it'll go ahead and apply that same filter. And this gives us that kind of consistency across all of our data models. Kind of these types of filters are really key for us since data in a data warehouse are typically scattered across multiple tables, whereas in like a transactional systems, that's something you deal with just like normalization. But for us, imposing these global filters allows us to control for that. So we can take kind of such practices from operational systems and apply them in a similar manner to, for instance, replicate a primary key constraint. These filters aren't really built in analytical data warehouses, but using and scaling this macro has allowed us to get similar benefits. One kind of unintended positive consequence here was that we've now been really consistent in our naming of columns. So kind of putting it all together and looking at the final architecture, we have this first step where, again, we're applying assertions that maintain our assumptions about the source data. And to my earlier point about issues going unnoticed, this is still where we would be catching those issues. But we add this additional layer called the source base, where we embed the filters that filter out the records that don't adhere to our expectations. So if we think about the assertions as more just an alerting mechanism, then the filters are closer to something like guardrails. And then finally, now that the source data meets our predefined expectations, we kind of similarly apply assertions to the output.
Yeah. Oh, okay, yeah, cool. Yeah, so just kind of to wrap that all up, basically what we've introduced and what we've started to use at Aiven ourselves is this kind of architecture where you still have tests. You have tests on your source data themselves. Those tests are set to warn so they don't break anything in your pipeline. Then the actual, the things that you're checking for in those tests are filtered out in this source base layer. And then on top of that, you have your data flowing as normal and being transformed as normal. So you're still aware of when changes happen upstream. You're not immediately affected by them, ruining the rest of your pipeline. And you're able to deal with those issues as and when you see fit. And you can kind of take a bit more of a step back approach where you have the time and the space to deal with these new incoming changes. So as an example, recently we had a product manager at Aiven come to us introducing a new product called Aiven for Metrics. It's not super important what it is, but they basically came to us and told us that, hey, we're launching this new product in a couple of weeks. What do we need to do? What do we need to tell the data team in order to make sure that all the data pipelines are still working and we don't break anything when we deploy this new product? Because we're going to get a bunch of new data, and some data is not going to be in exactly the same format or with exactly the same accepted values that we're used to. And luckily, this time around, we could just tell them nothing. You don't need to tell us anything. We'll know the second that it's deployed, because as soon as it was deployed and new data was flowing in, we got warnings on some of our tests saying, hey, there's data that doesn't conform to these expectations. But that data never filtered through and was never soft locking any of the rest of the data pipeline. So what this basically allowed us to do was to ensure that we have high data quality, that the data that our end users see actually meets the expectations that we have on it, for us to be aware of data changes happening upstream and be able to deal with them kind of in our own time. but also still be able to serve data in an incredibly timely manner and not have to, if one of us is out for a week, then maybe the data from that new product isn't flowing through, but all the other data is, and is still going through. So that's basically allowed us to, reduce the number of data quality issues, data incidents, stress, late nights, pings, whatever. Basically, it's a dream if you set up your architecture like this. So I'd encourage everyone to try and do that. I think to a large extent, that's it from us. We hope you guys enjoyed the talk. And if you have any questions, you can ask them now or after the presentation. I think we have about 3 minutes. But thank you all for your time and attention. Yeah, I think we might have a mic, because this session is recorded. I mean, I can also just try and repeat questions, but I think I saw your hand first.
Testing, 1, 2, 3.
Okay. Who's got their hand up? Here we go. Hold on. I got you.
Thanks for the talk, y'all. Really fabulous stuff. I have a question about your testing on your source data. When you set your tests to warning instead of error, what do you do with those warnings? Like, what happens if filtering out your bad data starts to distort your view of your data's reality? Like, what if your bad data is indicative of something that you actually need to go fix, like maybe broken field that you can't use anymore, CRM that's no longer meeting your needs? How do you distinguish between stuff that really is just noise and stuff that like you actually need to do something about?
Yeah, go ahead.
Sure. So we still look through and parse through like the Slack channel that has all of these warnings and all of these alerts. But it's now basically the difference there is we can have the time and the space to figure out ourselves how and when we deal with these issues based on the scope, the severity, the impact, rather than, I guess the difference there is rather than having a bunch of stakeholders hound you and having it, roll like a massive snowball getting bigger and bigger downstream, we can kind of like look at the issue just as its own, like on its own, and then decide how to prioritize from there. So we're still looking at these issues. They just don't impact the rest of the pipeline, so we don't have the stakeholder noise. But we still need to check ourselves. What is the use case that this is affecting? What is the severity, and how quickly should we try and deal with this? So I hope that answers.
Yeah, maybe just quickly elaborate on that as well. We still have the option to apply a test as an error. We were just kind of left that out. We wanted to focus here on the filters, but there's some tests, such as like a not empty, that we think of more of like a safety net that we do still run, but like by default, tests are just warnings.
There's loads of questions. I don't know where to start.
You pick it, I'll hit.
Do you want to go? Yeah, sure.
Okay, here you go.
Have you noticed an uptick in the number of backfills you've had to run as a result of those filters imposing assumptions that may not be globally valid when your stakeholders are iterating in the upstream?
Sorry, could you repeat that question?
Yeah, so my understanding of your architecture diagram indicates that you've got these filters that are going to be essentially stopping bad data from going into your downstream, right? So if those filters get outdated, or if they don't match what your stakeholders think they do, and your stakeholders are all of a sudden like, where's my data? Has that happened a lot? Have you had to fix that using a large number of backfills or anything like that? I'm just curious to know about your experience there.
Well, I would say no. Basically the way when we deploy, so say there's now a new service type, right, and we need to backfill that, then I'll open up a PR where I will add this new service type. That will trigger that this model has changed, and when we deploy that change, that will trigger a full refresh on the model, if that answered your question. Sure.
I think we have time for one more, and then y'all can feel free to come up and ask questions.
I guess way at the back.
Way at the back. All right, here we go.
Hey, thanks. Great presentation. I was curious how you guys compare your filters to a write, audit, publish paradigm, and if that was part of your evaluation process. I can define that as well, if you'd be.
For my sake, please.
Yeah, so the idea being like materialize the model maybe with a suffix like _staged, and then run data tests against that, and only if it passes, then zero copy clone it and overwrite the production state. So you, was curious if that was part of your consideration process.
Well, given the fact that I didn't know what that is, from my side it wasn't. But if I look at like some of the errors that we showed initially, like we found what was happening a lot of time was like a handful of records were malformed, and that was then hampering like an entire day's worth of data being updated. So in the kind of paradigm you outlined, I guess that would still happen, right? If you had 10 records that don't adhere to expectations in this stage table, the whole table wouldn't then update, right? Yeah. Yeah. So I think from our side, one of the big benefits of this is that the rest of the data still flows through properly. So I guess, yeah, but I mean, it's definitely something that I'll read about now after you've just introed it to me. But yeah.
Yeah, so what's your question, like, if that would have solved the problem of the bad data being in the table anyway, and if we consider that as a solution instead? Yeah, like the bad data in the table anyway problem is just like 1 out of 3, kind of where like the uptime or freshness of our models was really like, that was the big problem. So we wouldn't have solved for that. But it's for sure something we looked at, and yeah.
I mean, I guess you could see maybe what could be interesting as an extension of that is like data in that stage table that does adhere to expectations flows through. The rest maybe flows into its own further suffix table that you can then deal with later. I think that could be an interesting thing for us to look at for sure, because that would also deal with kind of the backfilling issue where we could process that data separately and then let it flow back in. So there's definitely extensions to be made to this idea. And yeah, appreciate both of the perspectives. Cool.
Yeah, thanks for coming.
Very much. And if you have questions, feel free to come up.